Hi dears, welcome to Brilliant Katha YouTube channel. In this video, we are going to discuss about an important topic for NEET and JEE that actually belongs to grade 11 equilibrium. Here, that is none other than pH calculation. Minimum, you will get one question for the competitive examination. So, let's look about the pH calculation. Actually, there are mainly 9 types are there. Okay, we are going to discuss one by one with example. Are you ready? Yeah. So dears, this is the first question they usually used to ask, how to calculate the pH of a strong acid. So whenever we want to calculate the pH, we must have to know pH is nothing minus log concentration of H plus. So if it is a strong acid means to calculate pH, we must have to know what is concentration of H plus. Correct? Yeah. So concentration of H plus is none other than, listen to me very carefully, that is concentration of H plus. Okay. So that means nothing, concentration of acid. That concentration also you have to take in terms of normality, not in terms of molarity. Okay. So concentration of H plus is equal to what? Normality of strong acid. Normality of strong acid. That idea you have to keep it in mind. Okay. So the acid normality they will give. So from that you can find out what? Concentration of H plus. Sometimes they won't give the normality. They will give the molarity. Then how we will find out the normality? Normality is nothing. That is equal to n factor into molarity. N factor into molarity. That normality, molarity, already we did one video that is there in the YouTube channel. You can check it there. Okay. I will give the link in the description box. Okay, so see, normality equal to, anyhow this is the idea, normality equal to what? N factor into molarity. That idea you have to keep it in mind. So if we know concentration of H plus, then we can easily find out pH. What is pH? Minus log concentration of H plus. That's the idea. Okay, so now let's look about one example. This is the example I given here. You can see, calculate the pH of 0.1 molar HCl solution. HCl is a strong acid that we know its molarity they given. Now they are asking about the pH. So in the case of HCl, that idea we know, in the case of HCl, N factor in the case of acid is equal to number of replaceable H plus, or else number of H plus donated. How many H plus HCl can donate? 1. So N factor is equal to 1. So normality equal to N factor into molarity. So that is equal to molarity itself. So in the case of HCl, NaOH and all, N factor 1 means no problem about molarity. Okay, directly you can take the molarity. If it is H2SO4 means their problems are there. Why? In the case of H2SO4, N factor is 2. Okay, that idea you have to keep it in mind. So anyhow, we can come to the point. Here the pH we have to calculate. So what's the concentration of H plus? Nothing. Concentration of H plus is equal to the concentration of acid given. Because it's a strong acid, directly we can write that is equal to how much? 0.1 molar. That means 0.1 normal. Okay, that is equal to nothing, 10 raised to minus 1 molar. Okay, then what's the pH? pH is equal to minus log concentration of H plus means 10 raised to minus 1. That means in the case of logarithm, you know that minus 1 we can take it outside. So minus 1 log 10, that is equal to how much I will get? 1. pH is equal to 1. Simple. Directly we got, yeah, pH is equal to less than 7 only will come at 298 Kelvin for strong acid. pH equal to 1. This way we can calculate if they are asking about strong acid. Clear? Yeah. Then we can go to the second type, that is pH of a strong base. pH of a strong base. In the case of strong base, they will give what? The concentration of OH minus. I mean the concentration of strong base, they have more concentration for OH minus. So you have to remember the concentration of OH minus is nothing, that is equal to normality of strong base. Normality of strong base. Normality of what? Strong base. Directly we can write. In the case of strong acid, concentration of H plus is equal to normality of strong acid. Here strong base. If it is base means OH minus. So normality of strong base. If we know the concentration of OH minus, then we know how to calculate POH. What is POH? Minus log concentration of OH minus. That is POH. Ready? Then if you know pH, POH, how we will calculate pH? pH equal to 14 minus POH at 298 Kelvin. If you know POH is some value. 1 means pH is equal to what? pH equal to 14 minus 1, 13. Like that we can calculate. Okay, so let's look one example. Here, calculate the pH of 0.1 molar NaOH solution. NaOH is a strong base. So the given 0.1 molar is not H plus, that is OH minus. That idea you have to keep it in mind. So concentration of OH minus is equal to, it is a strong base. So the given value, that is concentration of OH minus is equal to what? 0.1 molar. Sir, you told normality, then why you are taking molarity here? In the case of NaOH, molarity and normality are same because N factor of NaOH is equal to 1. NaOH can donate 1 OH minus. Clear? Yeah. So here concentration of OH minus is equal to 0.1 molar. Then how we will find out the POH? POH is equal to minus log 0.1. Minus log 0.1. Minus log 0.1 means minus log 10 raised to minus 1. That minus 1 I can take it outside. So 1 will be the POH. Then what is pH? pH equal to 14 minus 1, 13. Yes, answer is perfect. Greater than 7 is coming. Correct? Yeah, this is the way we are calculating. So 2 methods we learned. Now let's look about the third method. What's the third method? pH of a weak acid. Weak monobasic acid. Okay, weak monobasic acid. Then in the case of weak monobasic acid, they won't dissociate completely. They won't dissociate completely. Then we cannot write the concentration of H plus is equal to concentration of acid because that acid is not dissociate completely. Only alpha percentage only dissociate. So that's why we are taking concentration of H plus is equal to what? C alpha. C alpha. What is C? C is equal to normality of weak acid. Weak acid. And what is alpha? Alpha is equal to degree of dissociation. Degree of dissociation of weak acid. That is equal to alpha equal to, according to Ostwald dilution law, we know that is equal to root of Ka by C. That I am substituting. Then I will get another equation, root KAC. If alpha given means you can use C alpha. If Ka given means Ka is the dissociation constant of weak acid. Root KAC. That's the way we have to remember. So pH of a weak acid means whenever you are calculating concentration of H plus is equal to what? C alpha. Don't forget about alpha or else root of KAC. Root of KAC. Now let's look one example. This is the question they are asking. Calculate the pH of 0.1 molar acetic acid. Ka value they given. Whenever they are giving Ka, that time itself you must have to know, yeah, that is a weak acid. In the case of strong acid, no need of Ka value, no need of alpha value. Because their Ka value, their alpha value will be 1. I mean 100% maximum, completely dissociated. Correct? They cannot form an equilibrium constant. Equilibrium constant should not be there, okay? Equilibrium constant is only for the reversible reaction. Correct? Yeah. So here, in the case of pH, CH3COOH, acetic acid. Acetic acid is a weak acid. Correct? Yeah. So here, once we are looking, what's the concentration of H plus? What's the concentration? I cannot write 0.1. Why? Because that 0.1 does not dissociate completely. They do not dissociate completely. Clear? So what's the concentration of H plus for a weak acid? How we will calculate? Either C alpha or else root Ka into C. Correct? So here you can see Ka value they didn't given alpha. So what's the formula we will use? Root Ka into C. Root Ka into C. So that's equal to root of Ka value how much? 64 into 10 raised to minus 9. What is C? C means normality. In the case of acetic acid also, they can donate 1 H plus. So normality equal to molarity. That we can take it as 0.1 molar. 0.1 molar. So I can multiply with 0.1. So that will become what? Root of 64 into 10 raised to minus 10. 10 raised to minus 10. Whenever I am taking root is equal to root 64, 8. 8 into root of 10 raised to minus 10 means 10 raised to minus 5. Root means raised to 1 by 2. That idea you know. So this is actually concentration of H plus. If we know the concentration of H plus, how I can calculate the pH? pH is equal to nothing. That is equal to minus log concentration of H plus. 8 into 10 raised to minus 5. Am I correct? So how I will do it? We know the basic idea, log m into n. Okay, that is equal to log m plus log n. That idea I know. So what I will do, this is actually log m into n format. So I can write it as minus, I will take outside, logarithm of 8 plus logarithm of 10 raised to minus 5. Correct? Minus I am taking inside. What it will be become? Minus log 8 minus log 10 raised to minus 5. One more formula I know. What's the formula? Log a raised to m equal to, that m will come out. So m into log a. So this minus 5 will come out. So what will be getting? See, that's equal to pH equal to, I can write minus log 8 minus 5 log 10 minus 5 log 10. That will be log 10 is 1. So that become 5 minus log 8. 5 minus log 8. Log 8 how I will solve? Sometimes they will give you log 2. Okay, if they are not giving also, you must have to remember. So see, log 8 how we can solve? Log 8 means nothing. Log 8 equal to log 2 cube. Log 2 cube. Log 2 cube means, again this 3 I can take it outside. 3 log 2. Log 2 is 0.3010. That is equal to 0.9030. 0.9030. So that means 5 minus 0.9030. From, if you are subtracting 0.9050 from 5, how much is coming? See, 500.9030. This is 0. Here 7, here you can see 9 minus 3. 9 minus 3 means how much it will be coming? So that will be 6 will coming. Okay, so here 10 minus, 7 will be coming. 7 will be coming here. How much will be there? 9 will be there. Here 0. Here again 4. 4.097 will come. 4.097 will come. Am I correct? Yes or no? Ready? Yeah. So this is the idea for pH of what? pH of what? This one. pH of what? Here while you are looking, pH of a weak acid. That is pH of 0.1 molar acetic acid is equal to how much I am getting? I am getting 4.097. Correct? Yeah. Less than 7. But not near to 1. Ready? Weak acid. If they are asking the same question for a weak base, in the case of weak base also, that also does not, like NH4OH and all, they does not undergo complete dissociation. For that case, we must have concentration of OH minus they will give. So concentration of OH minus is equal to what? How I can use? Same formula, C alpha. But that will be equal to what? Root of Kb into C. Kb means what? Dissociation constant of weak base. Correct? Clear or no? Yes or no? So directly you can calculate it. If you know the concentration of OH minus means, you can find out POH. POH is what? Minus log concentration of OH minus. If you know the log concentration of OH minus means what you can find out? You can find out pH. pH equal to what? pH equal to what? pH equal to 14 minus POH. Like that you can calculate. Directly you can calculate. Clear or not? Yeah. So that 4 ideas we learned. 4 ideas we learned. pH of strong acid, pH of weak acid. Okay, pH of strong acid, pH of strong base, pH of weak acid, pH of weak base. Next one is pH of very dilute strong acid. Let me discuss with one example. If they are asking, see, listen to me. If they are asking, calculate the pH of 10 raised to minus 8 molar HCl. 10 raised to minus 8 molar HCl. How we will calculate? How we will calculate? Don't calculate like this. Like what? Concentration of H plus is equal to HCl. Molarity and normality are same. So 10 raised to minus 8. So yes, then H plus is 10 raised to minus 8. Then pH equal to what? Minus log 10 raised to minus 8. Yes, I got 8. Wrong. Utter nonsense. Why? In the case of strong acid, pH cannot be greater than 7. The answer is 8. That is wrong. Correct? Yeah. So what's the problem happened here? So this is wrong. Okay. This is wrong. So what's the problem happened here? The thing is that you have to remember, whenever your acid is very much diluted, that means concentration of H plus in the acid is, see, H plus in the acid is less than 10 raised to minus 6 molar. 10 raised to minus 6 molar. That time, what you want to do now, you have to concentration of H plus of total. Okay, total, whenever you are calculating, that's equal to concentration of H plus from the acid, as well as you have to take concentration of H plus from where? Water also you have to consider. That idea you have to keep it in mind. Concentration of H plus total equal to what? Concentration of H plus acid plus concentration of H plus from water. Why? In the case of water, while you are diluting, very diluting means that time that in water concentration of H plus is 10 raised to minus 7. That also you have to consider while you are considering the total H plus concentration. Clear? So the thing is that concentration of H plus from acid as well as concentration of H plus from water. What's the concentration of H plus from water at 298 Kelvin? 10 raised to minus 7 molar. That also you have to consider. While we are considering that one, this one will be this question. I asked already question, concentration of pH of 10 raised to minus 8 molar HCl. How we can calculate? Concentration of H plus total equal to concentration of H plus from acid plus concentration of H plus from water. Why we are not taking that water in the case of strong acid? Strong acid no need. Because that strong acid we took 0.1 molar. 0.1 plus 10 raised to minus 7. No, not necessary that 10 raised to minus 7. Here it is comparable. So 10 raised to minus 8 plus what? Concentration of H plus of water how much? That is actually 10 raised to minus 7. That also comparable. That two values are comparable. So both we have to add. That is equal to 10 raised to minus 7 into 0.1 plus 1. That means 1.1 into 10 raised to minus 7. That means 11 into 10 raised to minus 8. Then what's the pH? While I am calculating pH, minus logarithm of 11 into 10 raised to minus 8. That means, see, that's equal to how much it is coming? See, pH is equal to minus logarithm of you can see logarithm of 11 plus logarithm of 10 raised to minus 8. Okay, 10 raised to minus 8. Minus I am taking inside, so that will be become 8 minus log 11. 8 minus log 11. No need to remember about log 11. You can simply check the options. Log 10 is 1. Log 100 is 2. Log 100 is 2. So what about log 11? Log 11 will be in between 1 and 2. So that means 1 point something you are subtracting from 8 means 1 you are subtracting 7. 1 point something you are subtracting means approximately 6.9. That range answer will come. That means the pH of very dilute acid you don't want to calculate. You can simply check it. That answer will be just less than 7. Just less than 7. Clear? Okay? Yeah. The same way pH of very dilute strong base. Very dilute strong base, pH will be just above than 7. That's it. Okay. So here also you have to remember the concentration of OH minus is less than 10 raised to minus 6 molar means the concentration of OH minus from the base. Okay. That time concentration of OH minus total while you are calculating, that time you have to take concentration of OH minus from base as well as concentration of OH minus from where? OH minus from base as well as concentration of OH minus from where you have to calculate. That water you have to calculate. That means 10 raised to minus 7. Then you can calculate the POH. Then you can calculate pH equal to what? 14 minus POH. Like that you can calculate. Anyhow, here the pH value will be just greater than what? Just greater than 7 will get. Just 7.1, 7.2. That range will get. Whenever you are looking the options, you can easily answer. You can easily find it out. Clear, dears? Okay. Then we can go to the next method. That is 7th method. What's the 7th method? pH of mixture of two strong acid. If they are asking, if you are mixing 2 strong acid or 3 strong acid, what we will do? So in the case of, okay, see, in the case of mixture, I am taking acid 1. Okay, acid 1. Its normality is N1. N1 is nothing. That's actually the concentration of H plus in the first acid. And its volume is V1. And acid 2 I am having. Its normality is N2 and volume is V2. Normality is N2, volume is V2. If I am mixing both, I will get an acidic mixture. then see that normality of the mixture is N mix and volume is V mix. Then according to law of millimole equivalence, the total millimole equivalence is equal to the sum of millimole equivalence of each acids. That means millimole equivalence is nothing. Number of millimole equivalence means normality into volume. So the normality into volume here plus normality into volume here will be equal to normality of the mixture into V mix. That's the idea. So I can write N mix. Okay, N mix into V mix, that is equal to N1 V1 plus N2 V2. Then what is the N mix? N mix equal to N1 V1 plus N2 V2 divided by V mix. If I am mixing V1 volume and V2 volume, V mix equal to what? N1 V1 plus N2 V2 divided by V1 plus V2. This is the N mix. What is this N mix? I am mixing two acids. So this N mix is nothing. That's equal to concentration of H plus. So if you know the concentration of H plus, you know how to calculate pH. pH equal to minus log concentration of H plus. Directly you can calculate it. Idea clear? Yeah. So this is the idea. If you are mixing 2 or 3, 3 means N1 V1 plus N2 V2 plus N3 V3 divided by V1 plus V2 plus V3. That will be the concentration of that H plus total, H plus mixture. Then from there you can calculate the pH. Ready? Yeah, simple. Okay. Then if you are going to the 8th method, what about the 8th method? pH of mixture of two strong bases. pH of mixture of two strong bases. I am having strong base 1 here. So base 1, its normality is N1, its volume is V1. What about the normality? Normality is nothing. That's the concentration of OH minus in the case of base. Correct? Yeah. In the case of base, concentration of N plus is concentration of OH minus is equal to the normality. And base 2 I am having. Base 2, its normality is N2, volume is V2. And I am mixing means that will be N mix and V mix. Then here you can see, according to law of millimole equivalence, what I can write? N mix into V mix equal to N1 V1 plus N2 V2. N1 is the concentration of OH minus in the first base and N2 is the concentration of OH minus in the second base. Then what is N mix? N mix equal to N1 V1 plus N2 V2 divided by V mix. What is V mix? So, you know, N1 V1 plus N2 V2 divided by V1 plus V2. This is nothing but this is the concentration of OH minus. N mix is nothing but it's the concentration of OH minus equal to N1 V1 plus N2 V2 divided by V1 plus V2. That is OH minus. So if you know the OH minus mixture, then you can find out what? Then you can find out POH equal to minus log concentration of OH minus mix. From that you can calculate what? pH. pH equal to 14 minus POH. How easy it is? Simple. Clear or not? Yes. And the final one, 9th technique. What? If I am mixing one strong acid as well as strong base, what will be the pH? How we will calculate the pH? Idea simple. I am having a acid, its normality is N1, Na. I am taking Na. What is Na? Normality of acid. That is nothing. That's the concentration of H plus because I am taking the strong acid. And if it is weak acid means C alpha. Simple. Okay. Na normality. We know how to calculate. Then what about the case of volume? Volume is Va. And I am going to mix this one with what? A base. Its normality is Nb and volume is Vb. If I am mixing, then the normality of the mixture is N mixture, volume of the mixture is V mix. V mix is nothing, Va plus Vb. If I am adding acid and base, that volume is adding. But number of millimole equivalence is not adding. Here NaVa is the Na into Va, normality into volume, that is called a number of millimole equivalent. That for acid as well as number of millimole equivalent of base also I can calculate, NbVb, number of millimole equivalents of base. Number of millimole equivalents is equal to normality into volume. Here for acid NaVa, here for base NbVb. Once I am mixing acid and base, they will undergo neutralization. That means subtraction will take place, not addition. That millimole equivalent I am not going to add, I am going to subtract. Correct? So, see, there are three cases will be there. In that case, case 1, if NaVa is greater than NbVb, that means number of millimole equivalent of acid is greater than number of millimole equivalent of base. Then what will happen? That mixture will be acidic. That mixture will be what? Acidic. So how I can write? Normality of the mixture is equal to, from acid number of millimole equivalent, I have to subtract base number of millimole equivalent. Then divided by volume, I have to add Va plus Vb. This answer will be acidic. Therefore, that will be equal to H plus of the mix. pH will be less than 7. Correct or not? Yes or no? Yeah. Similarly, if case 2, in the case of number of millimole equivalent of acids is less than number of millimole equivalent of base, then that normality of the mixture I have to calculate from higher to lower, I have to subtract. So NbVb minus NaVa divided by Va plus Vb. But that mixture, here the base is more. So the mixture will be basic. So that will be concentration of OH minus mix. If I know concentration of OH minus mix means I know how to calculate POH minus log concentration of OH minus mix. Then from that I can calculate pH equal to what? 14 minus POH. And the case 3, what about case 3? Case 3, if NaVa equal to NbVb, both will neutralize. Then what will be the pH? pH will be equal to 7. That's all about the 9 method of calculation of pH of acid and base. I hope you guys got it very clearly. You have to, if you have any doubts regarding this one, means you have to pin your comments in the comment section. We can meet in another video, another beautiful video with this kind of commonly asked questions areas and with examples and all. I will come again with this kind of videos, guys. See you in the next video. Thank you so much.